Hi, this is Brent the Climate Guru. In this portion of our series of podcasts, Climate Basics, Climate Insights, we're going to discuss tipping points, which are certain levels of increase in temperature and how to avoid them. And we're going to talk about the carbon budget. How much more carbon can we emit into the atmosphere before we reach certain tipping points to avoid 1.5 degrees Celsius or 2 degrees Celsius, certain dangerous levels of increase in temperature. Which of the natural systems on Earth absorb carbon and which ones emit it? So I hope you enjoyed this part of the series. Thank you. And let's look back in the history of the Earth. The last time the Earth had 400 parts per million of carbon, and we have 425 today, was millions of years ago. And the Earth's temperature were 2 degrees Celsius to 3 degrees Celsius above the amounts that we call pre-industrial. That's 3.6 degrees Fahrenheit to 5.4 degrees Fahrenheit. That's a very, very high temperature. Would make life on Earth something unknown to what we have today. So it is indeed the amount, and it's a frightening amount that we're approaching. We must do all we can to begin to reduce that. So where does the excess carbon go? Well, a lot of it goes into the atmosphere and enhances the greenhouse effect. Some of it, about 1 or 2%, is absorbed into the land, rocks and soil. And about over 50% of it is absorbed by trees, vegetation, and into the oceans. If we didn't absorb that amount of excess carbon, the greenhouse effect would be much, much worse. The Earth would be much warmer. Now, the oceans absorb about 25 to 30% of the excess carbon emitted by humans. The oceans contain 71% of the Earth's surface, and thank goodness they're able to absorb these vast amounts of carbon. But the oceans are being negatively affected by that. They're becoming more acidic, and that's being measured. And what does that do to marine organisms and life? Well, higher acid amounts in the oceans inhibit certain marine organisms from developing their shells, lobsters, clams, shrimps, and so on. So that is indeed a problem that's been studied and monitored. The oceans also absorb 93% of the excess heat, which is created through the greenhouse effect, the enhanced greenhouse effect caused by humans. If the oceans didn't absorb all of this heat, the Earth would be 60 or 7 degrees warmer than it is now, which would be an uninhabitable planet. So what happens when the oceans become warmer? Well, one of the negative side effects on the oceans is that warmer water can hold less oxygen. We know that marine organisms, fish, and others, they breathe oxygen just like we do on land. More heat in the oceans reduce the amount of oxygen. So it's more difficult for marine creatures to survive. Fish are smaller because of reduced oxygen, because of increased temperatures, and there's less abundance of fish. Now, another concept that we hear often is called the carbon budget. And what is the carbon budget? Well, we know how much greenhouse gases we emit into the atmosphere. Early in the century, it was by the way, it's measured in billions of tons each year, which they call gigatons. So early part of the 1900s, we emitted about 3 gigatons human activity, 3 gigatons, 3 billion tons of carbon into the atmosphere. That slowly rose over the 1900s as we became more industrialized in the world, not just the United States. And we reached in the around 2000 about 30 gigatons, 30 billion tons of carbon each year globally. And now, the last few years, we are at about 41 gigatons of carbon emitted into the atmosphere each year. So what is the carbon budget? Well, scientists tell us that in order to maintain temperatures below a certain point, we only have a certain amount of carbon left that we can emit into the atmosphere to stay below those amounts. That's the carbon budget. How much more carbon can we emit into the atmosphere to stay below 1.5 degrees Celsius? How much more carbon can we emit into the atmosphere to stay below 2 degrees Celsius? That is what's called the carbon budget. And every year we use up parts of the budget. We approach 1.5 degrees Celsius temperature rise or 2 degrees Celsius temperature rise as we use those up. Scientists tell us that at the present rate, the budget for 1.5 degrees may be a couple decades, and for 2 degrees, it may be around halfway through the century, around the year 2050. The budget is left before we reach those temperatures. So where does the carbon come from, at least in the United States and in similar industrial nations around the world? Transportation provides 28% of carbon emissions. Cars, trucks, airplanes, and so on. Electric power generation is 25%. And as I say, we move from coal to natural gas, which is 50% of the amount of carbon of coal. We need to move away from natural gas into renewable sources, which are capable today of producing all the electricity we need in the world. We have the technology, and it's much cheaper per kilowatt hour to produce 1 kilowatt hour of electricity with solar or wind compared to developing that 1 kilowatt hour through natural gas generating plants. It's much, much cheaper. So we can move in that direction, and we will move in that direction. Electric power is 25%. Industry is 23%. Residential and commercial heating, cooling of our homes and offices and buildings is 13%. And agriculture is 10%. People are surprised that agriculture has such a high amount of emissions of carbon and other greenhouse gases. One of the big problems that we face with agriculture is certain animals, especially cows, their digestive system emits, as they release gas, their digestive system emits very large amounts of methane, which we mentioned is a very potent greenhouse gas. Another item which produces lots of carbon is the process to make cement. The chemical process to make cement emits very large amounts of carbon. Obviously, the United States, as it developed, Western Europe emitted much of that. But the biggest emitter of carbon from the creation of cement is China, as China is exploding in development. So looking at the countries that emit carbon today in the world, how are they ranked? Which countries emit the most? Which developed countries emit the least? Well, China emits about 33% each year of all the carbon dioxide into the atmosphere. It's by far the largest. It continues to develop by building coal plants to develop electricity. The United States is in number 2 position of the Western industrial countries at 14%. We are number 2 in the world in the amount of carbon emissions that we put into the atmosphere. But we're only 4.5% of the world's population, and we're number 2 place with 14%. Number 3 is India. India emits 9.5% of the world's carbon, also a huge amount. So China's number 1 at about 33%, the United States about 14%, India at 9.5%. What's next? Russia is next at 5.8%. Then we have Indonesia at 8%, Japan at 3.5%, all of the European Union, 27 countries, about 5%, Brazil at 5.5%, South Korea, which is a developed industrial country, at about 2%, and the others in the world combined to 13%. Now, we mentioned earlier that carbon remains in the atmosphere for hundreds or thousands of years. So of the amount of carbon that's in the atmosphere today, what countries, what parts of the world are responsible for that? Well, I guess it won't surprise you that the United States is responsible for the largest amount of carbon that remains in the atmosphere today. This is the historic contributions of carbon emissions. We're responsible for about 20% of all the carbon in the atmosphere today. So the United States is number 1 in cumulative historic carbon emissions that still remain in the atmosphere. And China is in 2nd place at 11%. Germany is in 6th place at 3.5%, since it also industrialized early. Western Europe, especially England and other Northern European countries, are less than 10%. So the United States is number 1 in cumulative carbon emissions by far. China's number 2, Russia's number 3. Brazil's number 4. Indonesia is next, number 5. And Indonesia not only is developing with industry, but it tore down large amounts of the forests in the late 1800s and continues. Germany's next, and then India, England, and then so on and so forth. Now, another interesting statistic is how much does the United States emit per person of carbon, and what do the other countries emit per person, per capita, of carbon each year? Well, I'm not going to mention certain Gulf states, which are very small, but they have the highest because they emit so much carbon. But near the top is Canada at about 16 tons of carbon per person per year. The United States is about 14 or 15 tons of carbon per person per year, a very high level, as we'll see, because of the very advanced industry and economy that we have and the luxury that we enjoy. China, about 8.8% of tons of carbon per person emitted per year. The United States, remember, is only 4.5% of the world's population, but we emit very large amounts, 50% of carbon, tons of carbon per year per person. So let's look at the promises that were made by the world's countries in Paris in 2015 to reduce the amount of carbon emissions. Promises made by the United States, the rest of the world, if kept, would not be sufficient to avoid certain increases in temperature. The problem is that the promises we made, if kept, are not sufficient to keep greenhouse gas emissions in control, in check, and they're not sufficient to meet the goals we need to do to stay within the carbon budget and keep temperatures from rising to dangerous levels. One of the problems is we are reducing coal production by 30%. We're actually increasing oil and gas production by 33% oil and 27% gas. The United States is now the largest producer of oil and gas in the world. We are an exporter. So scientists tell us in order to meet these goals of excessive global warming, a world that we can't recognize at the end of the century, we have to keep 2/3 of fossil fuels in the ground: oil, natural gas, and coal. We know we have the technology to do that. The renewable energy sources, which are, of course, hydroelectric, photoelectric from solar, and wind on both land and in the oceans offshore, the technology's there, and it's cheaper to produce a kilowatt of electricity from them. And so we must move more quickly to those renewable sources. We have a carbon budget. We still have time left. We have a few decades to sharply reduce our emissions of greenhouse gases. And we can do that if we have the political will to do that in the United States and around the world. We've been a leader in the world, especially in Paris. Obama went there and was able to convince China to make certain promises. So we have to continue our leadership. The global South, Africa, Latin America, they have a very small percentage of liability, responsibility for greenhouse gas emissions today and historically. And they look at the global North, the industrialized rich world, and say, you guys are responsible. We're not responsible for what's going on in the past or present, and we need help. We need money so that we convert our electricity generation to renewables. We need the technology to do that. The global North has made promises, certain amounts of money, but it really hasn't delivered. So the developing world is looking at the global North, the United States, Europe, and other countries for leadership to lead us to a world that becomes a healthy, safe, and habitable world that our children inherit and look back and be proud of what we did. Thank you, Climate Guru, signing off. Thanks for tuning in to the Climate Guru podcast. Stay inspired, stay informed, and keep taking action for our planet's future. Until next time, and remember, together we can make a difference.